All right, so the goal for this lesson is to come up with a way to determine where the extrema of a function are analytically. And to do that, we have something called the first derivative test. And so let me explain. Let's just recap what extrema are, right? So there are two types of extrema. There's local, or another term is relative extrema. So those are interchangeable words, and global and absolute extrema. So a relative or local extrema are any peaks and valleys on a curve. And so what I mean by that, that could include the endpoints. Those could be relative extrema. By the way, not all teachers or mathematicians include endpoints as relative extrema. Some will argue they're not, and others will. AP tests will never confuse that for you. There's no trick questions, but just for the purposes of discussion, I will always include the endpoints as relative extrema. And so that includes the endpoints and any peaks and valleys, any relative maximum or minimum within a small domain. So for instance, in this local region, there's a relative maximum at this point. It's the highest, it's a high point, it's a peak in this region. It's not the highest of the entire curve, but it is a high point for a small domain, a localized domain. And so then I come to this point right here. So some people might think, oh, that's another relative max, but notice it's not labeled. So this is not a relative max because it doesn't really change. It's actually decreasing the whole way. It's not really peaking there. It's just kind of flattening out and then continuing decreasing. So for that reason, we cannot call that a relative max or a min. And the same thing happens here. The function seems to just keep increasing. It kind of flattens out a little bit, but it really never peaks or valleys out or any of that. So you have to have a full-on peak and valley. We're going to define this more precisely in just a moment, but it's just sort of an intuitive sense of what these are. Now, global extrema are the absolute highest and lowest point of your function in a specified domain. So in this picture, we can see that the low point actually is occurring at an endpoint. It is the absolute minimum or global minimum. And then this is the highest point on the curve. So this is the absolute maximum or global maximum for the function. It's also a relative maximum, but that's neither here nor there. It's both. So you can have that at the different extrema. Okay, so the global distinguishes itself because it is the highest or lowest point for the entire function in the given domain. All right, so a method to find the local extrema is going to use critical points. So recall what that is. What makes something a critical point? So that is where f prime, put that back down. Okay, so the critical values, I guess I'm not writing. There we go. Critical values where the first derivative was either equal to 0 or the first derivative was undefined. So we're going to, if we locate those, then we can test around that to find, remember we talked about where a function's increasing or decreasing. So if f prime is changing from positive to negative, so let's say it's positive on one side of a critical value, and c is the critical value that's mapped here, and the first derivative is negative on the other, what does that mean? Remember what it does with the function f? That means that f is increasing where the first derivative is positive and decreasing where the first derivative is negative. Well, what does that look like? F is increasing, and then we have a critical value. So let's say the critical value, that's where the first derivative is 0. That would mean it would flatten out. But then it starts decreasing again. So notice that means this point right here has to be a maximum, or at least a local maximum, if not the maximum. It's a local maximum for sure. So how did that happen? Our first derivative changed from positive to negative, and we find a local maximum or relative maximum. Then the second case is where we test values around the critical value, and the first derivative changes from negative to positive. So just switching the signs. Well, what does that mean for f? So my function f, means that f is going to be decreasing when the first derivative is negative. So my function is going down. And then let me move this a little bit up so I can see it. And then f prime is now positive. So that means my f of x is increasing. So it's going back up. And what do we get right here? That's going to be a relative minimum. All right, so just to sum it all up, our first derivative test involves these steps here. We first determine any critical values in the domain of f of x, where f prime is 0 or undefined. Step 2, we use the first derivative to test intervals around the critical values. We know that we have a local minimum at the critical value if the derivative, so they're using the letter A here for critical value, okay? So if f prime, so let me change it to C just to be consistent with our lesson here. So we'll just switch that out just so it's not confusing. I want to be consistent. So there's a local minimum at that critical value if the first derivative changes from negative to positive. There's a local maximum if the first derivative changes from positive to negative. All right, so that is a summary of the first derivative test to find local extrema.